Let's consider how we can find the delay of any filter. So given a filter's transfer function h of z, what is the delay through that filter? Well, we need to evaluate the frequency response of the filter before we can find its actual delay. Frequency response for a digital filter is defined as the filter's transfer function evaluated on the unit circle. That is, let z be the complex value e to the j omega. This is helpful if we sketch this. So think of the function h of z being plotted over the real and imaginary parts of z. If we picked specifically omega equals 0, then e to the j 0, is the vector as I've just drawn, horizontal vector. That corresponds to our DC frequency. Now as we start to increase omega to larger and larger values, that vector starts to trace out a path in the complex plane. Since the vector has a fixed radius, what it does is traces out a circle, that we call the unit circle. So the key points on the unit circle are the DC frequency, that is 0, the sampling frequency, that corresponds to value of pi, and the folding frequency is half of the sampling frequency. When we want to consider the frequency response of a filter, we are typically interested in evaluating that response from DC out to the folding frequency. So we can think of this as evaluating our transfer function h of z along that arc in the complex plane. Now the frequency response is a complex valued function of omega. So let me just reiterate that we have h evaluated at e to the j omega. That gives us in polar form a magnitude response and a phase response. So this is just simply expressing that complex valued function in polar form. The magnitude response, we can think of this as the frequency dependent gain, and the phase response also is dependent on frequency. Turns out that the delay through the filter, which I'll call tau of omega, representing a time delay. Delay through the filter is the derivative of the phase function with respect to omega negated. You can think of this in words as the negated slope of the phase response.